Hello and welcome to day 2 of the How to Get Started with Solana Development in 2026 series. Today we're going to talk about the fundamentals, the concepts you really need to understand in order to do anything on Solana. In particular, we're going to define what is an account, an instruction, a transaction, a program, all core concepts to Solana development. So don't skip this one. Unless you already know those things, then of course you can do whatever. Again, I'm not your mom, I'm not telling you what to do. So if we have anything to discuss, let's not waste time and get started right away with what is an account. So yesterday we had this idea of the Andy has this much money, Anatoly has this much money. Those are the accounts. Think of it as a bank account. On your bank account, you have a certain amount of money. And now on Solana, that's similar, just that this account doesn't live on some server of your bank, but it's stored on the blockchain. All of the accounts make up the so-called state of the blockchain. And in case you're familiar with the Bitcoin blockchain, they do it differently. They use UTXOs, so unspent transaction outputs. Basically, whenever they do a transfer, they have the inputs and the outputs, and the outputs then become inputs for the next transaction. Ethereum does it differently. Ethereum went to an account model where they don't remember the outputs, but they remember for each account the number, the actual number of what is in there, which conceptually is also easier to understand. So we don't even need to worry about the UTXOs. Let's just go with the accounts model. Solana also has this accounts model. Every account has a certain amount of SOL. And then you can say Andy's account has so much SOL, and Anatoly's account has so much SOL. Great. In addition to the SOL that is on the account, it also stores some metadata, like the owner, which we will discuss tomorrow. And also, as we already mentioned yesterday, an account can have data. So it might not just store how much SOL is there, but it can also hold arbitrary bytes. But also that we will explore in further detail tomorrow. For now, let's stay with the idea of an account has a certain amount of SOL. And maybe this is also already a good time to introduce lamperts. When I say an account has a certain amount of lamperts, then I'm talking about the SOL just in higher resolution. One SOL is 1 billion lamperts, because most often an account will not even have one entire SOL. They might have just a few thousand lamperts. It's the same concept as with Satoshis on Bitcoin or Wei for ETH. And that is also the smallest entity. You cannot send half a lampert because we're working with full integers here, and that's just integer arithmetic. You can send half a SOL though. That would be 500 million lamperts. And one lampert really isn't anything, really. Thousands of lamperts is usually when it becomes interesting. Okay, anyway, so an account has lamperts. Great. But now this is very static. Okay, we take a snapshot of all of Solana. We have the accounts, and we can see for every account how much SOL is on there, how many lamperts. Great. But that would be quite boring if that would always stay the same and you can't change it because... So we need a way to change those accounts. For instance, to send lamperts from one account to another account. And that's where programs come in. A program defines what should be done to their accounts. You can think of a program like a library of functions. And each of those functions defines some input parameters, so the arguments that this function takes, and then it has an implementation of what it does. You know, the code that is executed when the function is called. And one such function could, for instance, log something to the ledger, or it could transfer some SOL. So there could be a program that has a function called transfer SOL, and this function takes as input parameters the account it should transfer from, the account it should transfer to, and the amount of lamperts that it should transfer. That would be the arguments. And then the implementation could look something like, if the sender account has fewer lamperts than is the amount specified, we return an error. And otherwise, we decrease the sender's lamperts by the amount, and we increase the receiver's lampert by the same amount, and then we return. That could be the implementation of this function. Note that we usually call this a program instruction then, but I don't want to confuse you with what an instruction is, so let's stay with the idea of this is a function of that program. And a program can have several of those functions. And now there are several programs on Solana, and we as developers, we can write our own ones. That's what we're gonna do tomorrow. And now, in order to actually do something on chain, we gotta somehow call those functions of the programs. And that we do with creating an instruction. An instruction now basically just says, that's the program I wanna call, that's the function of the program that I wanna call, and that's the arguments. That makes up an instruction. For instance, I can create a transfer sol instruction by providing the sending account, the receiving account, and the amount of lamperts. And of course, the correct program. What is the correct program? Solana does have a few core programs which contain functionality that is essential for the chain. For instance, transferring lamperts. So there are pre-existing programs that can do those things. One of them is the system program. And the system program has this function, which we call an instruction, to transfer lamperts. So we can create a transfer lampert instruction with the system program. Now we have an instruction, great, but somehow we need to actually get that instruction to be executed. Because for now it's just that the instruction is just saying, yeah, please do that. But by itself, that's not just happening. So we need a transaction. A transaction can hold instructions, several of them, or also none, but that doesn't really make sense. And that transaction is what we will then send to the RPC, which will then send it to a validator. And the validator then puts that transaction into a block, which means at that point all of the instructions are getting executed and the state is being changed, and the state changes is being broadcast to all of the other validators to update the state. So with the block being accepted by consensus, the state is actually changed on the blockchain. So to recap, to change an account, we need to create an instruction that calls a program, put that instruction into a transaction, sign that transaction, but we haven't talked about signing yet, and that transaction can then be put into a block to actually perform the update and execute that program. Now, one last thing here, those programs, that's not something that's running on Solana. Like, don't think of it as a program that is constantly running, like a service or something. That's why I said you can think of it as a library. Basically, the program really just is this list of machine code instructions, add that value, change that value, and so on and so on. And that program is being run when an instruction of the transaction is executed. So basically the validator runs that code, sees what the changes are, and persists the changes. That's done by the runtime that runs this. And yeah, when we write the program and we deploy it to Solana, it's basically just our code being there. It's not that we need to have a service running or something. Okay, that was a lot of talking in the beginning. I hope you're still with me. Let's look at that in practice. Yesterday, we created this account. Each account has an address, so that's where it lives. That's what we need to find this account. If we know the address, we can look up how much sol is on that account. What we also did was a simple transfer. Solana, transfer to which address? I can transfer to myself for fun, 0.1 sol. So the CLI here builds an instruction, puts it into a transaction, and sends that to the DevNet cluster. That's what it looks like. And here we see it. It has one instruction to the system program. It's a transfer instruction. So that transfer, that's the function that I was talking about. And the from and to addresses, as well as the amount, that's the arguments that I was talking about. Now, what we can also do is tell the CLI, hey, I want another instruction in there. I want to write a memo. So let's do the same thing with memo. Hold on, I'm gonna clear this so that you see better. With memo, I don't know, thanks for all the fish. Then, if we look at this transaction suddenly has two instructions. One to the system program again, the same transfer to myself. And then one to the memo program, calling the memo instruction. See how this is confusing, right? We call this an instruction, the instruction of the program, but then we call the instruction as well, the thing that contains which program to call and what the parameters are. That's really what I mean when I say an instruction. But this is an instruction of the program. We use the same word for that. It might be confusing, but yeah. So the instruction here, the second instruction, what does it contain? The program to call, and then what function to call, and then the actual parameters. In this case, the string that I want to log. And what does that program do? Well, it just writes something to the log. So this is a so-called ledger of Solana. This is not persisted in any of the accounts, so it's not in the state, but it's just in the ledger. It's still persisted. If you know the transaction signature, then you can look that up, but it's not updating any account like the system program transfer instruction would when we actually transfer, to a different account. So if I send somewhere else, I could send to Anatoly, not a real wallet address. I can't have an L, obviously. There we go. Those two work. So with this address, it should work. Yeah, it's not funded. We need this. It's not it's an actual address. It's a valid address. If I send Sol there, then it's lost forever. Don't do this on mainnet because nobody has the private key for this public key. Maybe there is not even a private key. So anything that we send there is lost. But the point is, if we look at that transaction, it again has those two instructions. One transfer instruction where I send from this account to this account 0.1 Sol, and then one memo instruction, thanks for all the fish. So this instruction changes the state because Andy will now have 0.1 Sol fewer and Anatoly will have more. Or this account, it's not really Anatoly's. Okay, makes sense? So to recap, we put instructions into one transaction to modify the accounts. Now, this thing already hints at something essential in Solana. We said this is an account and this is an account. Okay, good. So far I'm sure you can follow because that's also what we had here. Andy's and Anatoly's account that have some Sol balances which are changing. But then check this. The system program and the memo program, they also are in the list of accounts. So that means they are also accounts. Yes, because everything on Solana is an account, they say. Really everything? Well, no, a transaction is obviously not an account. But to make it easy, any program is also just an account. Yeah, it has an address and it has a certain amount of Sol. But here, this account also has actual data in the form of bytes. And that's basically the library that is uploaded here, containing the functions and the implementation for the memo instruction. Same with the system program. The system program has a very special address, all ones in base 58, which is all zeros. This thing just has 14 bytes and is still owned by the native loader, but this will change. There's a migration process happening from native programs to core programs that I'm not gonna discuss here because we're still talking about the basics. So that's how we change state using the CLI. But now I want to do the same thing with TypeScript. So we're going to install the TypeScript package called Gil. So I'm going to use pnpm to install Gil. There we go. Wonderful. Because in this Gil package, there's all sorts of helpful stuff that really comes from a package called Solana Kit, but Gil re-exports all of that and contains more helpful functions. That's why for now, when getting started, I like to use Gil because I want to have a look at those accounts, instructions, and transactions. So getting started with accounts. Oh, by the way, one more sentence to that. There's an older TypeScript SDK for Solana called the Web3.js. However, I do highly recommend that you work with the Kit or Gil, same, because that's what's still being maintained. And this is a how to get started with Solana development in 2026 after all. So we want to use the tools that are recommended right now and not the deprecated stuff that might not be maintained for long. Okay, so let's get started with accounts. Let's say I just want to know what the balance of my account is. So what do I need to know for that? Well, I need to know the account's address. So where does that account live? In the kit, it's all very functional here. So I can create an address with this address function, and I'll put in a string with my address. That will return my address. Cool. Now, to get the account for that address, I need a way to ask the state of the blockchain. So I need to somehow query Solana and be like, hey, I want to read this. You know, same way we do here with the Explorer. Hey, this account, give me the info for this account. And what's happening here is that in the background, an RPC function is being invoked that gives me that information. Because remember, yesterday we talked about validators and RPC clients. The RPC client is what we're interacting with. So in the kit, I can say create Solana RPC and give it the cluster URL. If you're not sure, you can always say Solana config get. This will give you the cluster URL right here, the API devnet.solana.com. Just gonna paste that in here. So we go to devnet, that's the cluster. So that will be my RPC. And with that RPC, I have those nice functions. And one of them is the get account info. That's what I want to do. I want to get an account info for an account at a certain address. I give you the address, and that's already enough. The defaults are okay for commitments and stuff. And this just creates the RPC request. To actually send it to the RPC with the kit, I need to say send. That will then actually, do the networking stuff and communicate with the RPC. That's going to take some time. So I'll have to await this because that's async. But then I get back the account info. No, actually, what do I get back? I'll call that RPC response. And this response has the context for which slot we're currently in. So how far in the blockchain we are. It gives me context for that state that I queried, because obviously the chain keeps making progress and I'm always just querying for a certain point in time. More blocks are being produced, and here it tells me at which block we currently are. The context here has the slot, a slot just being a possibility for a validator to produce a block. So in the ideal world, every slot would contain a block, but in some slots, no block is being produced. That's the distinction here. And it gives me as context the slot, like how far we advanced in slots. But I'm not too worried about that. I'm really interested in the actual value that I get back, because that is then my account info. And the account info, here I have all the things that make up the account. So space tells me how many bytes that account has in data. Data are the actual bytes that the account holds. We don't need to worry about executable. That's going to be deprecated, I think. And we're going to talk more about the owner tomorrow. But what I'm really interested in today is just the lamperts. So that's the amount of sol. And if I really want the sol amount, then I need to just multiply that with lamperts per sol. And the kit is being a bit weird with this is not a number, but it's a type lamperts. So I need to get the actual value of it as a big int. And then I can only multiply it with another big int. So I need to make this also a big int. Then I can get the sol amount. And that would look like this. I'll just log my account has this much. So let's try and run this. This is not Solana specific. That's just TypeScript being TypeScript. Just gonna do this. Voila. So just put this in a quick async function that I'm calling directly here because I don't have top level weight. There we go. Ooh, I was being stupid. Of course, it's not a multiply by lamperts per sol. I need to divide. Oops. And then I get 0 because this is not a freaking integer, because obviously I don't have one sol and we're dealing with integers here. Gonna make this a number first, then I will have floating point. There we go. That's what I wanted. I can get the information how much sol is on my account by requesting that information from the RPC. That also lets me get the account data, but for now we're not too worried about actual data. We're just interested in the sol amount. Okay, let's create an instruction. So we want to change that amount now. Now we want to actually transfer some sol. What do we need for that? First, We need an instruction to do the transfer. That's fairly simple. Now we do want to interact with a specific program, namely the system program, and most programs have some interface available. For the system program, it's in Solana program/system, because this thing will now have a get transfer sol instruction. And here we already said which instruction, so which function we want to call of which program, the system program. And so we just need to provide the parameters, namely the amount, the source, and the destination. So amount, how much do I want to send? 0.1 sol, but the amount is in lamperts, so I'll multiply with lamperts per sol. The source I can say is my address, but this will not work. We'll see in a second why. And the destination, I'm gonna send to Toli again. Gonna make a receiver address, Toli. Now, this doesn't work. Why not? Because in order to send something from an address, the system program requires proof that we actually own this address, such that not everybody can send from every address, because then nobody would own anything. Therefore, we need to prove that this is our address. And how do we prove that? We went through that yesterday. Well, with our private key. So we need to be able to sign. The source needs to be a signer. So not just an address, but a signer. And we have the private key for that. Remember this one. This is a key pair that we have stored locally. So we just need to somehow get access to that in our TypeScript. There's a nice little helper function in here. Now I need to have access to the file system. So regular TypeScript doesn't do that. I need TypeScript node, which I have, but then also I need to import from gil/node. In here, it has the corresponding functions that have access to the file system. And I want to have the load key pair signer from file. That's what I want. So I can say my key pair is load key pair signer from file. And then I just get the one that we have, my key pair that we generated yesterday, this thing. And this key pair, oh, I need to await this. There we go. That's async. There we go. This is now a key pair signer, and that thing has an address. So I can just say my address is the key pair.address instead of hard coding this myself, because that key pair should have that same address. Or I don't use that at all. But my point is, from the key pair, if I want the address again, I can say .address. Here I need to provide the entire key pair, source my key pair. Then it doesn't complain anymore. Then I still give it the receiver, the Toli, and voila, I have an instruction. So this is my transfer sol instruction. There we go. And now to be able to actually, execute this, I will need to put it into a transaction. Exactly. So conveniently, Gil has this create transaction. What does that take? It takes instructions. So I'm just gonna put my transfer sol instruction in an array. So I just have this one instruction. And then every transaction needs to have a fee payer. That is the account paying the transaction fees. Because on Solana, if you want to send a transaction, it costs some sol. The base fee is currently 5,000 lamperts per signature, and you can add priority fee, but that's a whole different topic. I have videos on that. For now, we just specify who pays for that, and I'll make it easy for myself. I let my key pair pay for it. That's also what the CLI did. And like that, I have a transaction. There you go. However, there's one more thing that this transaction is missing though. We need one more thing. We need a lifetime. Every transaction needs to have a lifetime that basically says how long that transaction is valid. There are two ways to provide a lifetime: block hashes and durable nonces, but the second one, durable nonces, will be removed at some point. So let's just go with the regular lifetime strategy, which is a latest block hash. And I don't want you to worry too much about that for now. We can just get that from the RPC, get the value here, and then we have a latest block hash. Easy. We just need to do this. Add a lifetime. So you just got to remember that a transaction consists of the instructions, a fee payer, and a lifetime, in our case, a latest block hash. Now we're still not quite done. We have all the information, but before we can send it, we still need to sign this transaction. We did provide the signers here and here, but there's just one more step that you got to do with a kit. Let's get a signed transaction. Sign transaction with signers. And I give you the transaction. And then let's log get signature from transaction of this signed transaction. So like this I can sign. And now we just need to send this transaction. And there is a send and confirm transaction factory, which might seem a bit counterintuitive. You basically have to create the function that you want to call. If you're not used to functional programming, then that's a bit weird maybe. And what this needs is the RPC, which we have, and RPC subscriptions, because to confirm the transaction, we want the WebSocket. We have to have an open connection to wait for the result. So we're just also gonna create an RPC subscription, create Solana RPC subscriptions, and same address, just that I'm now using WebSockets. And then that should work. And this factory gives me a function. So my send and confirm transaction function is what I get back from this factory. And now we can use that function. We can just call it. And what do we give it? The transaction. Actually, Gil does that differently. Gil has a create Solana client where we can say, give it to me for DevNet, and then we get the RPC and a send and confirm transaction. So we don't need to do this weird stuff with the kit. And then we can use this send and confirm transaction to send our signed transaction. It's that easy. And then afterwards I can say console log confirmed after I awaited this. Cool. Like this. I'm going to show you the entire thing again. This is my entire script. I create this Solana client that gives me the send and confirm transaction. Let's see if that would actually run. Yep. Look at this. And it got confirmed. I can also look at that in the Explorer. There are different Explorers, by the way. I did once make a video where I compare them. I like the Solana Explorer from Solana Foundation. It's just what I got used to. So yeah, we see this transaction has one instruction to the system program where we transfer from this address to this address 0.1 sol. And we can look at the account overview here and we see Anatoly, the address got another 0.1 sol and we paid for this. So we are the fee payer. Here you see it as well. The fee payer pays the fee. Additionally to what I sent, I also pay the fee. Nice. And we also saw how we can do this in TypeScript. So from a local client. So this is how you programmatically could send the transaction. The easiest way. And now if we wanted to do more in the same transaction, we certainly could. We could add a memo instruction here as well. I would just need to get the Solana program memo. Then I can get a add memo instruction. So get add memo instruction with the input, the memo, which is a string. So I should say thank you. And then I could add this instruction in here. Maybe I send a little less this time because I'm running out of sol. And then I send that. It's being confirmed. Great. If we look at that in the Explorer, we see we once again paid the transaction fee. We sent 0.01 to this account with this transfer instruction. And then we also added a memo instruction, and the memo spells thank you. So now we have two instructions in this one transaction. Okay, I mean, that's nice and simple, right? With Gil, this abstracts away most of the complexity to make it easy for us to send our first transaction with TypeScript. Now let's get a little bit more technical here still. We said a transaction contains several instructions, but a transaction also has a list of accounts. And yes, that includes the programs that are being called, because as we said, everything is an account, also the programs. And this is how Solana might be different to other blockchains that you might be used to. A transaction needs to contain all the accounts that it reads or writes from. You cannot have a transaction that modifies or even just reads from an account that is not within the list of the accounts of that transaction. This will just not work. Furthermore, for every account that is written to, so every account that should be changed by the transaction needs to be flagged as writable. Why is that important? Through doing so, transactions can be processed in parallel. Because we know all the accounts that are included in the transaction, so we know what part of the state of Solana is being accessed. And if another transaction accesses another part of the state that doesn't overlap, or it overlaps but it's just read access, then those transactions can run in parallel. And that's how Solana reaches its high throughput. But it's somewhat inconvenient for us developers, because we already need to know upfront what are the accounts that we're working with. So we have a list of accounts. Every account is marked as writable or read-only, and an account can also be marked as a signer. If it is a signer, then a signature for that account needs to be present. So in our case, we had to sign with the private key of this account, but also that we'll go into in more detail soon. For now, I just want you to know that every transaction has this list of accounts and a list of instructions and a fee payer and a lifetime. And in most cases, this will be a recent block hash. Now, if a transaction is successful, then the accounts that the instruction changed will actually be changed. So the state is updated, but only if the transaction is successful. A transaction can fail for many reasons. In our case, for instance, if we try to send more SOL than we actually have. If I were to attempt to send 10 SOL, then the system program instruction would fail, and so our transaction would error because instruction 1 failed, instruction 1 being the transfer of 10 SOL, and in the logs we see insufficient lamperts. And what's important to note here, if any of the instructions fail, then the entire transaction fails, and it is as if the transaction wasn't even executed. In this case, the memo didn't even get executed anymore. So let's say I had 2 transfer instructions. The first one would transfer 0.1 lamperts and the second one 10. Then even though the first transfer actually succeeded, because the second transfer doesn't succeed, the entire transaction fails. And because a transaction is what we call atomic, so it's either the entire transaction succeeds or it doesn't, it's as if this instruction was never executed. So the state change of this instruction is not persisted because an instruction afterwards failed. That's important to know about Solana transactions. The only thing that is still being changed is we still pay for the transaction fee. Yeah, when we talk about transactions, them being atomic is certainly one thing that you should know. Only successful transactions are actually persisted. This might have already been a lot of information, so we're gonna leave it at that for today. As a homework, I want you to create yourself a script like this using Gil or the Solana kit directly to send a transaction. I'm not too worried about what instructions you send. You can play around with it yourself. If you want some inspiration, maybe you create 2 key pairs and send back and forth between them. First transaction sends there, another transaction sends from the other key pair back, just to see which key pair you need to sign with now and so on. So the goal is sending transactions from TypeScript. Now, I can't leave you without the more technical explanation for the instruction. I wanted to save this for the next video, but no, it's so essential. I think we gotta fit that in here. So let's look at that in a bit more detail, what those instructions really are from a technical perspective. If we look at this transfer sol instruction, for instance, it has those three fields: the program address, the data, and the accounts. Those three things make up every instruction. So far I said it's a function with arguments of a program, but that's a simplification. In reality, it's a program, accounts, and data. So the program, that's simple enough. That's the address to the program. Every program has an address because we said that everything on Solana is an account. So the program also lives at an account, and therefore it has an address. So we put the program address. So far so good. But then I simplified it and I said the function and the parameters of the function, but really which function it is part of the data, and the arguments is both the accounts that it takes and further instruction data. But I don't want to confuse you with this today. There are these neat little helper functions where we can just, provide the arguments. So we say, hey, this function of the system program with these arguments. But we will dig deeper the next few days. So looking forward to seeing you back. Okay, what did we learn today? Today we learned that everything that is stored on Solana is stored in an account. Every account has lamperts, so a sol balance, and every account can have data. To change the state, so to change the data or the lamperts of any account, we need instructions. An instruction is made up of the program it calls, the instruction data, which includes which function of the program is called, and which accounts are required for that instruction. And then those instructions are put into a transaction. A transaction has a fee payer, a lifetime, in most cases a recent block hash, a list of accounts where each account also can be flagged as writable or as a signer. And of course, the transaction contains the instructions. A transaction can fail or succeed, and it's atomic, so only if every instruction succeeds, that transaction is also successful. Otherwise, the state is reverted. I hope you could still follow so far. We will get more technical with every day in this series. Tomorrow, we're gonna write our first program and really see what it's about with that data. So far we've been just working with sol. Tomorrow we'll actually work with data, and we will learn about the owners. Since every account has an owner, tomorrow we will have a look at what that is. So if you're ready for tomorrow, I'll see you there. Otherwise, here's some other videos. Don't forget your homework. Do send the transaction with the kit just to try it out once. And tomorrow we write our first program. Until then, sleep well.